In this video, we're going to talk about circles, some new vocabulary, and then some properties of tangents. So first, let's talk about what is a circle. So a circle is simply the set of points that are the same distance away from a point we call that center. So all of those points on the circle are the same distance away from that center. And then the radius is simply a segment that connects the center point to the edge of the circle. So any point on the circle. Those two you're probably more familiar with, but a chord is a segment that connects any 2 points on the circle. Okay, so that would be a chord. I could do a chord that goes like this. So it can be anywhere in the circle as long as it connects 2 points on the circle. And then a diameter is simply a chord that goes through the center. So the diameter still connects 2 points on the circle, but it also goes through that center point. Okay, and again, you know what diameter is, but that's a definition now knowing the word chord. And then we also have lines that go through the circle. The first one is called a secant line, and it goes through the circle twice. It intersects the circle twice. So it's almost like a chord, but it doesn't stop at the edge of the circle. It goes through and keeps on going. And then we have a tangent line. A tangent line only touches the circle once. So it just skims that surface of the circle. And then where it intersects the circle is called that point of tangency. So something you might want to make note of in your notes is that these are all segments and they stop at the edge of the circle. Whereas these are lines and they go on forever and ever. So let's look at some examples so we can see if we can identify these new pieces of the circle. So we're going to see whether it is a line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. So AC. AC goes from here to here. So notice that's connecting the center to the edge of the circle. So that means that is a radius. And now I'm going to do AB. AB goes from here to here. So it's a chord that goes through the center. That means it has to be a diameter. And then if we move on to DE. DE, here's D, here's E. So notice that is just touching the circle once at point B. So that is a tangent. And notice that D and E are on a line that goes on forever. And then AE, let's see, A, here's A, and here's E. So it's also on a line, and it's touching the circle twice. So here at G and here at A. So that means it is a secant line. All right, so now let's look at some properties of tangents specifically. The first property is that we know a tangent line is going to be perpendicular to the radius. That has to be true. So you see how they have that perpendicular sign there. All right, so if we want to know in this first example if TS is tangent to this circle P, we need to know then is the radius right here perpendicular to TS. So we really need to know, is angle T a right angle? So in order to do that, notice that this makes a triangle. They kind of gave us enough information to make a right triangle. So we need to see if that's a right triangle. We don't know for sure. So the first thing we need to do is use our Pythagorean theorem. Remember, a squared plus b squared equals c squared. And since we want the right angle to be at T, then 37 needs to be our C. So I need to put 37 over here for my C, and then the 12 and the 35 go in for A and B. So let's do that. Let's see if that's equal, because we don't know that for sure. So 144 plus 1225, let's see if that's equal to 1369. So I'm going to add these two together on the left-hand side, And yeah, I do. I get 1369 on the left and 1369 on the right. So that means, yes, TS is a tangent. Okay. So now let's do some more examples. In these examples, we're trying to find the value of the variable. So in this first one, x is our variable. We're trying to find that length. And it does say in this one that it is a right angle. So we know that AB is a tangent to that circle. So I know that 80 is across from my 90 degrees, so that has to be my c squared. And then my x and my 48 are the a and the b. So I'm going to have x squared plus 2304 equals 6400. Then I'm going to subtract that 2304. That gives me 4096. And then to solve for that x squared, remember we have to do the square root on both sides. So that gives me x equals 64. So we found the value of that variable. That's all we had to do on that one. Now over here, my variable is r, and it shows up both here and here. So remember that if this is supposed to be 90 degrees, then this side is one side of my right triangle, 80 is another side, but this side over here is not just 50 and it's not just r. It's the whole thing is 50 plus r. So that's a little different than what we're used to. So if I'm making my Pythagorean theorem, r is going to be just one plain old side. So I'm going to have r squared plus my 80 squared. And that's going to be equal to this side over here that's across from the 90-degree angle. That's 50 plus r squared. Notice that I put 50 plus r in parentheses because I want to square that whole thing. So I'm going to have r squared plus 6400. But remember back from Algebra 1 that parentheses squared means that I have two parentheses that I multiply together. So I have to distribute that. So let's distribute. Remember distributing is when I'm doing 50 times 50, 50 times r, and then r times 50, and then r times r. So if we do that, I'm going to get 2500 plus 50r plus another 50r plus r squared. Over here, we still have the r squared plus 6400. So what do we do with all this stuff? We're going to combine our like terms. Those two are like terms. That's going to bring everything else down. But if I do 50r plus another 50r, that's 100r. And now I need to combine the r squared. They're on opposite sides, so I have to cancel it over here, line it up over there. But notice that they both cancel on both sides. So I have 6400 equals 2500 plus 100r. So now this is just a simple linear equation that we're used to solving. I'm going to subtract the 2500. That's going to give me 3900. And then I'm going to divide by that 100 on both sides, and that's going to give me r is equal to 39. So my radius of that circle is 39, and we had to do a lot more work on that one in order to solve that. So now let's look at another property of tangents, and that is that if I have tangents going to the same point outside of the circle, then I know that those two tangents are going to be congruent to each other. So I have TS as a tangent, and it intersects just at T, and RS as a tangent, it intersects right there at R, and they both come to a common point S. And it kind of reminds me of like an ice cream cone or like a birthday hat on top of a head. So if we look at this first example, I've got two tangents coming to that point outside of the circle, so I know that those are congruent. So we just set up an equation. 3x plus 4 equals 20. I'm going to subtract the 4 and then divide by the 3, and I get x equals 8. No big deal. On this other one, this next one, number 4, again, I have those two segments are congruent, so I'm going to set 3x squared minus 10 equal to 17. And remember, this time I just have x squared that I'm getting by itself instead of plain old x. So I'm going to add that 10 over to the other side. That gives me 27 on the right-hand side. I still have 3x squared on the left side. And then I'm going to divide both sides by 3. And then now I need to square root both sides. So I'm going to get x is equal to 3. And remember, we only have to worry about the positive one, not the negative one. Well, in this one, I guess it could be plus or minus. So we have plus or minus 3 because it would be squared in our original equation. And then number 5, we have same situation. I have those two segments will be congruent, so we're going to set up an equation stating that 2x squared plus 3x minus 2 equals 3. But now I have both x squared and x in there, so we have to use the quadratic formula. So I need to, in order to use the quadratic formula, I need to have 0 on that right-hand side. And so that means I have 2x squared plus 3x. Here I'm going to have minus 5. Also remember from quadratic formula, back in Algebra 1, we have a equals 2, b equals 3, and c equals negative 5. And our formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. So let's plug that in and solve it. So I'm going to have x equals negative, my b is 3, then I'm going to have plus or minus b squared, so I'm plugging in 3, minus 4 times a, which is 2, times c, which is negative 5, all over 2 times 2. So what I would suggest you do is make sure you use parentheses when you type this into the calculator. Just type in the stuff that's underneath the square root. Okay, and if you do that, you should get 49. And then if you do 2 times 2 in the denominator, that gives you 4. And then now we can do the square root of 49. The square root of 49 is simply 7, so I have plus or minus 7 over 4. And remember that the plus or minus means I really have two different answers going on. I have negative 3 plus 7 divided by 4, and I have negative 3 minus 7 divided by 4. So I'm going to have negative 3 plus 7 is 4, and then 4 divided by 4, that's 1. So that's one of my answers. And then negative 3 minus 7 is negative 10, and negative 10 divided by 4 is negative 2.5. So let me double check and make sure that the negative one would give us a positive answer. So if we plug this in, I would get a positive number here, and then a negative number here. So would that be too big? Let's see. Let's pull up our calculator. If I do 2 times, let's see, 2.5 squared, that gives me 6.25. So I'm going to have 6.25 here. And then if I do 3 times 2.5, and that's a negative, then that's going to give me negative 15. Ooh, yeah, that won't give me a positive answer. If I add all those together, that'll give me a negative. So we don't want to have that negative right there. Okay, so that's the only thing you would have to worry about with the quadratics is you want to make sure that your answers don't give you negative values because that doesn't make sense in geometry. All right, we'll do some more examples in class.